All right. Diving into the early universe today.
Yeah, going way back.
We're talking about something so massive, it makes our sun look like, well,
Like a grain of sand.
yeah, pretty much.
Black hole stars.
Black hole
They're
stars.
not your typical stars.
No, not even close, I'm guessing.
Not even close.
So we're talking, what? Stars that can swallow up
Solar systems.
whole solar systems.
Easy.
Okay, now hold on a second. How do we even get something that big?
You got to go back to the beginning.
Okay, so we're rewinding the clock to
The early universe.
the universe, all right?
A few 100 million years after the Big Bang.
Yeah.
Now imagine
Okay.
the universe is just a chaotic mess.
Oh, I bet.
Dense, hot, overflowing with hydrogen gas.
Everywhere. So this is before stars? Before...
This is like the first act.
Okay, so we just got this, like, cosmic soup of...
Hydrogen, yeah, and dark matter.
Ah, right, dark matter. And that plays a role here.
Oh, it's pulling the strings.
Okay, how so?
So dark matter, it clumps together,
Uh-huh.
forms these massive structures, dark matter halos.
Halos.
They're like gravity wells,
pulling everything in.
pulling in all that hydrogen gas.
So it's setting the stage, kind of.
It's building the foundations
Let's hold stars.
for everything, really.
Yeah.
Stars, galaxies, you name it.
So how do we get from, giant clouds of hydrogen to a star, let alone a black hole star?
Gravity. It's the master chef.
All right.
Inside these hydrogen clouds, the densest parts, they start to collapse,
Okay.
pulling in more and more gas.
Like a runaway train?
Exactly.
Makes sense.
And as it grows, the pressure, the heat, oh, it's off the charts.
And then boom.
Boom.
Yeah.
Nuclear fusion ignites.
A star is born.
A star is born.
But these early stars, they were different.
Oh, they were breaking all the rules.
Right, because a star can only get so big, right?
There's a limit.
So what was different back then?
Well, think about it. Normal star has got a size limit. Outward pressure from fusion, it balances out the gravity.
Okay.
But these early stars, they had a secret weapon.
Which was?
Those dark matter halos we talked about,
Right.
they were like an endless supply of hydrogen.
So these stars could just keep growing and growing.
Absurd sizes. How absurd are we talking?
Cry 10 million.
10 million.
10 million times the mass of our sun.
10 million suns. It's unimaginable.
It boggles the mind.
And that's when the black hole comes in. That's when things get really interesting.
All right. So we've got this massive, massive star.
Unfathomably massive.
And all that mass is doing what?
It's putting incredible pressure on the core.
Like a pressure cooker about to explode.
Even more intense than that.
Okay.
And eventually, that pressure, it's too much. The core collapses.
And that's how you get a black hole.
That's the recipe.
But wouldn't a black hole just tear the star apart?
That's what you'd think, right?
That's what I'm thinking.
But here's where things get wild.
All right, hit me.
The star, it survives.
It survived.
It's so massive that even a supernova can't destroy it.
Wow.
So now you've got this tiny black hole.
Tiny.
Well, relatively speaking.
Okay.
Maybe a few tens of kilometers across.
Okay.
Inside a star larger than our solar system.
So it's like a
cosmic parasite.
A cosmic parasite, and the star is...
The unsuspecting host.
Wow, so then what happens?
It doesn't just hang out, though. It's got a huge appetite.
Right, because it's a black hole.
The star is basically the next meal.
So the black hole is pulling in that star stuff, and the star's trying to hold it together.
Exactly. It's a cosmic tug of war.
So what happens? Who wins?
Well, the black hole keeps eating, getting bigger, more energetic.
And that affects the star how?
All that energy's got to go somewhere. Heats up the star, makes it expand.
And expand, like how much are we talking?
We're talking bigger than our solar system.
Wow.
And it's not just getting bigger. It's blazing with energy. Jets of plasma shooting out.
Like cosmic fireworks.
You got it.
Wow, what a way to go. What happens to the black hole after?
After the star's gone,
Yeah.
it's free.
Just out there roaming the universe.
Roaming, eating, growing. It could become thousands of times heavier than our sun.
Thousands of times.
At least.
Okay, back up a second. You said these black hole stars. They could explain supermassive black holes.
I did say that.
So how does that work?
Well, we see these supermassive black holes at the center of galaxies.
Right, even our galaxy has one.
Exactly. But they're huge.
Huge is an understatement.
Billions of times the mass of our sun.
Yeah, billions. And we've never been quite sure how they form.
Exactly.
Because even if a regular black hole just ate and ate and ate
It would take longer than the universe has
to
existed.
get that big.
It just wouldn't add up.
But black hole stars, they
Yeah.
could be the answer.
They're the missing link, maybe.
Okay, walk me through this.
So these black hole stars, they already have a head start.
Right, they're born huge.
And they just keep growing, eating matter, merging with other black holes.
And eventually,
They become the anchors of galaxies.
the supermassive black holes we see today.
It's a pretty mind-blowing idea.
It is, but how do we even know if any of this is true?
Well, that's where things get really interesting.
Okay, you gotta tell me.
We have telescopes now,
Powerful ones.
the James Webb, for example.
The James Webb, yeah.
They can see so far. It's like looking back in time.
To when black hole stars existed.
We could actually see them.
Or at least see what they left behind.
Exactly.
So we're looking for, like, cosmic fossils.
In a way, yeah.
What kind of fossils are we talking?
We could see the afterglow of their explosions.
The explosions, right? When the black hole ate the star.
Or maybe gravitational waves,
Sure.
ripples in space-time.
From something that massive, I bet.
Oh,
So it's like a giant cosmic treasure hunt.
And the James Webb is our metal detector.
Looking for clues to these ancient titans.
And if we find them,
That would be huge.
it would change everything. How we understand the early universe. Black holes, galaxies,
All because of these black hole stars.
they're a key to the past.
This is incredible. When I thought we were diving deep before.
Well, we're just getting started.
So we're looking for what? Like cosmic dinosaur bones?
Something like that.
Except instead of digging in the dirt, we're searching for light. Light from billions of years ago.
It's a whole new kind of archaeology.
And if we find these fossils, if we prove black hole stars existed, what then?
That's the best part. Each discovery leads to more questions.
So what mysteries could they help us unlock?
Well, for one, we might finally understand how the first galaxies formed.
Because of black hole stars.
It could have been the seeds, the gravitational anchors that pulled everything together.
So they're not just a cool concept, they're essential to understanding the universe.
Exactly. Black hole stars could change everything.
It's incredible to think something that massive, that powerful, could hold the key to the early universe.
And we're just getting started.
That's the craziest part. We're constantly learning new things.
And pushing the boundaries of what we thought was possible.
Black hole stars are definitely proof of that. I mean, when we started this deep dive, I had no idea how much there was to learn.
There's always more to discover. That's what makes the universe so fascinating.
Exactly, and who knows what other mysteries are out there, just waiting to be uncovered.
Well, one thing's for sure. When those discoveries are made, we'll be here to break it all down. Right here on The Deep Dive.
Until then, keep looking up. And never stop exploring.